Alright guys, so now we are going to still be on section 6.8, page 358, but we are going to work on the problem number 43. Okay, so in this problem number 43, what do we have? We have a system of inequality x plus y less than or equal than 5. Then we have 2x plus y less than or equal than 8. We have now x greater than or equal than 0, y greater than or equal than 0, and the constraint p, which is the last equation now, 4x plus 3y. Alright, so what do they want? Well, they want us to grab the constraint, determine the vertices of the feasible region, and then use the vertices obtained in part A to determine the maximum and minimum of the profit. So, that is the equation of the profit, and in order to use it, we need to represent each of these inequality. So to that, we are going to apply what we did in a problem number 13 or 29. First of all, I'm going to have y by himself. I subtract x by both sides. Because I'm subtracting, my symbol doesn't change, and I'm supposed to have a minus x plus 5. For the other one, I'm going to have y less than or equal than minus 2x plus 8. For these two inequality, the slope m equal negative 1, and the y-intercept is going to be 0, 5 if I substitute the less than or equal by just an equation to be able to draw my line. For the other one, m equal negative 2, from the y-intercept, 0, 8. So, you know what? Let's try to represent this graph right away. So, I got my y-axis and x-axis. And the first point I'm going to represent is the first intercept, 0, 5. So, let me represent the first y-intercept. Take another color, here we go. So 1, 2, 3, 4, and 5. So that is 0, 5. And from this point, because the slope is negative 1, I need to go down 1, right 1. Now, there is an equal inside my inequality symbol, so I'm supposed to have a solid line. And because y solid line, and because y is less, I'm supposed to shade below. Now, for the other one, I'm going to take the green, and the y-intercept 0, 8, so 5, 6, 7, and 8. So from this point, I need to go down 2, 1, 2, and right 1. So again, there is an equal in my symbol, solid line. Alright, solid line. Now I need to represent the two other lines, the two other inequality. First of all, x greater than or equal than 0. When x greater than or equal than 0, if I'm using and I'm putting equal 0 and y equals 0, when I'm graphing the first one, what do I have? So let me use the purple for the x. Alright, when y equal whatever, x will be always equal to 0. So no matter what value of y I'm going to choose, x will be equal to 0. So the first line I'm going to have is this one. That is x equals 0. And for the other one, let me take another color, and I'm going to take the color I'm going to take the blue. For the other one, I need to graph y equals 0, and for any value of x, y will be always equal to 0. So that means I'm getting this. And what do I see? I see 4 vertices. First one, second one, third one, and fourth one. Why? Because when you look at the first one over there, x greater than or equal than 0, because it's greater, I need to shade to the right. And for the other one, I need to shade above. And what do I see is pretty nice. Let me take some yellow. That basically in this space right here, all the shading are above each other. And so I have 4 vertices. Each of these vertices will be defined by coordinate, and for each of these vertices, I'm going to use their coordinate and plug the value of x and y inside the equation of the profit. And so I have the point A right here, I have the point B right here, I have the point C and the point D. Now you will understand that because of my graph is not very accurate, my coordinate will be less accurate. So what you have to do, basically, again, is plug the coordinate of XA, YA, and calculate the profit every time you are substituting the value of x and y by the coordinate of each point, so xd and yd, and you will be able to define for which vertices the profit will be maximum and minimum.